Okay, Algebra 2, our last lesson of the year, 8.5, logarithms. Logarithms are going to look very, very different. This is a topic that you never would have seen in past math classes. Although maybe your chemistry teacher, if you were taking chemistry, it's very possible that your chemistry teacher introduced a logarithm to you there. Because that's what a pH, a power of hydrogen, really is. It's really a log. But look at this. You'll see log. You're always going to see a base, a number down below. That's a subscript. You're going to have the log base b. Some number inside of the log will have y, and then set it equal to x. Right now, this is going to look very strange. You can probably think, my gosh, I don't know what that means. It's just another way, guys, and please get this, of having this relationship. A lot of teachers here at Maine East, and actually all across the nation, use something called a log circle. You can see I've just drawn in a log circle. And that can help you know what every logarithm really is. Start down at that base, way down low, and just start making a circle. And then look what that means. You start down low. It's b raised to the x power. And then set that equal to y. So I'm going to cross this out. These are the interchangeable forms. A log is just another way of writing this exponential equation that you see over here. I'm going to highlight it in blue. You can go from the log form to the exponent. You could also go backwards, start where I am in blue, and then write it as a log. One thing I always write, and I think it's really helped kids a lot, is you recognize that the base of the log is the base of the exponent. And if you remember that, you're going to be in real good shape. The base of the log, you can see right there, that's b. It's also the base of the exponent. And you can see that b right over here. That can be extremely helpful. So we can make ourselves a little log circle, and it can help you out big time. Look, these first problems, for example 1, they can look very strange and foreign to you, but look, if you make a log circle, you'll be able to change this to an exponent. Draw that log circle in. And then guess what we're going to write? You're just going to have to write this. 3 raised to what power? The second equals 9. Notice what we did. We start down here at the base. We raise it up to this number right here. Then we set it equal to 9. Kids will say, what is this logarithm stuff? It's just another way of expressing that exponent. You guys help me out with this next one. What do you think number 2 is going to be? Help me out. What do you think we're going to write? Yep, 10 to the negative 1. Set it equal, and then what do we write? 1/10. You're done. You're done. Those are some of the basic problems that you're going to see on homework. Also on tests. If you remember your log circle, you're going to be fine. Let's go to Roman numeral 2 here. Sorry, it should be 3. And we'll make ourselves a little log circle again. So 5 to the 0 power, set it equal to just a 1, and we're done. Okay? Yes? Well, write it 5 to the 0 power. 5 to the 0 power is equal to a 1. Now we're going to go backwards. We're going to go backwards. Now, here's the thing. When you're going backwards, guys, you need to be able to use the log circle to check that you're right. This is where I want you to realize the base of the log is the base of the exponent. The base of the log is the base of the exponent. So the power, I think you can always see, is up here. That's a 5. But what's your base here? Your base is 2. So I'm going to write log of what base? Log base 2. Now, the power always gets set equal to the log. The power always gets set equal to the log. And the last number that you have will go inside. Sometimes kids will say, I don't know if I did it right. Use a log circle to check. Here's what I'm saying. If you've done this right, you could still draw your log circle to see if you're right. This would say 2 to the 5th power would equal 32. So how do we do these? You find the base of the exponent, that's also the base of the log. The actual exponent, the actual power, is always going to go on the right-hand side. So help me with number 2. It's 3 to the 4th equals 81. So what's the base of the power here? It's a 3. So I'm going to have log with what base? 3. And the power is a 4. So do I put the power inside the log? No, the power always is equal to the log, right? And then you put your 81 here. Now, sometimes kids are saying, I'm not sure if I got that right. Do a log circle to double check. You'd go 3 to that 4th power would equal 81. So even here, you can use your log circle to make sure you're right. Let's take a look at number 3. What's the base of this power here? 0. It's a 2, right? The base, the actual power is a 0, right? So I'm going to go log of what base now? Log of base 2. The power of 0 is actually over here. You put your 1 inside. You'd say, well, how do I know I'm right? Well, do a quick log circle. We'll go 2 to the 0, set it equal to 1. Okay, and then for our last one, this is really number 4. What's the base of our power here? It's 5. Your power is a 1, so you got to put your power. Your power is set equal to the log every time. And then you'd say, well, wait a minute. There's still a last number remaining. There's still this 5 over here. That goes inside. I know that can look weird when you see repeated numbers. But it's 5 to the 1 power would equal 5. And that's exactly what you get. Okay? There is a second page. There is this second page, guys. And here's the cool thing. Solve for x and simplify as much as you can. Guys, the most important part of today's lesson is knowing the log circle. So let's make a log circle together. Help me. Look at 2a. What should I write from a log circle? We're going to get what? No. Start down low. 7 to the 2 is equal to x. That's your log circle. What's 7 to the 2nd power? 49. So we'd get x is equal to 49. That's your final answer. For B, do a log circle. Guys, if you keep doing your log circle, things are going to really work out for the best. Always start down low. What should the log circle tell us? What do we get? Where do we start? X. Bump it up to the 2 power. X squared. Set it equal to 36. Now at this point, we're solving for x. And it is going to be 6. Now one little word of caution. Some of you are going to remember when we were solving this, there were 2 square roots. You get plus or minus 6. What you have to remember is all bases are positive for logs. All bases are positive. So it's true that solving, real technically, you would actually get an answer of plus or minus 6, but officially it's just the positive 6. Okay? Let's take a look at letter C. Help me with the log circle. What do we get? Look at that. How do I write it? X to the negative 1 power would equal 1/10. There are two ways you could solve this, guys. There are two ways you can solve. One of which would be you could raise x to a power, and that would be fine. If you see this, you could say, well, really I want to get x to the 1 power. I want to get x to the 1 power, and I could raise both sides to a power to help me do that. What power do you think I'd have to raise it up to? Powers to powers get multiplied. Guess what we'd get? -1. Okay, so what we'd see is this would be x equals, well, think about it. Another way you could write this, 1/10 to the -1. We could type that in, and we could even go alpha y equals, we'll go 1/10, raise it up to the -1 power, and sure enough, you'll get 10. Okay? Another way you could have solved is, would you agree that a negative exponent flips it? You take a reciprocal. X to the -1, that's 1 over x, right? Then you could cross multiply. Look at that. 1 times x is x, 1 times 10 is 10. You get the same thing. You get the same thing, guys. All right, take a look at D real quick. Help me with the log circle. What do we get? 9 to the -2. We're going to get 9 to the -2, and then we're going to type that in. Now, guys, as you type that in, you're going to get a decimal. Please remember you can hit math, frac, and you'll get 1 over 81. Here we go again with this opposite reciprocal. With this reciprocal, when you see 9 to a negative power, we bring things down. We take a reciprocal. You could even do this without a calculator. Right? Look at that. That's 1 over 9 squared. 9 squared is 81. So that's really what you got. Well, it wouldn't give you credit if you put 1 over 9 squared. You have to simplify. Okay? All right. The last ones are really just working out to the nearest thousandth using your calculator. So this is where you want to have your calculator out. And as we do this, guys, it'll say log. Your log button's right next to the 7. This is log base 10, by the way. This is known as the common log. And going to 3 decimals, you'd get 1.421, but just to the right of the third decimal is a number bigger than 5. So this becomes 1.422. 1.422. Just button pushing, guys. By the way, that's understood to have a base of 10. ln, this one you have a base of e. That's the other log button that you're going to see on the calculator. That's right next to the 4. So I can take ln, go second square root, type in a 6, and just hit enter at that point. That's 0.895, but to the right, you've got a number 5 or bigger, so it's going to be 0.896. Then we're going to have to come down over here and get some help. For these next problems, guys, please go to math and go all the way down to actually past 0 to a. And then you could just go log base 6 of 1 and very quickly get an answer of 0. Look, right below that, I'm just going to hit second enter and retype it. Here's log base 4 of, when you hit 16, you'll get it too. You can come back over